Hello and good day. My name is Aaron Tan and will now teach you how to create a smart traffic light system that detects the presence of a car using ultrasonic distance sensor in Tinkercad. So first thing that we have to do is go to this components basics here and select status Arduino. This will give us the default placement of the breadboard for the Arduino. And place it, so it looks like this. So the black wires are connected to the ground and to the breadboard itself. And the red wires are connected to the 5 volts, so you will have the power. Now we go to the basics component and select our ultrasonic distance sensor. So we can select this one, place it somewhere here, or maybe here. The second one, you can choose up to any number you want, depending on how many traffic lights you want to place in that certain area. So you can select this one, and to rotate, you can press the R key in your keyboard. And as you can see, you can rotate, or you can press this button over here. Now I will place it somewhere around here. So now that they are both placed, they are not connected yet, so we are going to connect them. When you look closely, you can see the ultrasonic distance sensor has 3 pins. First pin is ground, second pin is 5 volts, and the third pin is SIG. So the SIG is actually connected to the signal pin, which as you can see over here. So when we want to connect them, first we select this color here so that the wire itself will be black color because we're going to connect the ground pin first. So let's take here, can connect to this part as this is the black wiring. So it will connect directly to the ground over here in Arduino. Next, we're going to connect the power pin in red wire and place it over here. Now the power pin is also connected to the Arduino in the 5 volts pin. Now for the signal, first of all, let me change that. Now for the signal, zoom out first. We are going to connect it to one of the pins over here. You can choose any one of the pins except for 1 and 0 because they are built-in pull-up resistors. So they may affect your results becoming 0 in your input or something. So you first change it to yellow or any color that you prefer. Select the signal. Click here, all the way down to any number you want. In this case, I will put around at 8. There you go. And as it's connected, you now connect this second ultrasonic distance sensor. You can choose any pin as well. I mean, you can choose any pin you want. Go to the bottom, put it a bit further, and towards the D9. Then connect the rest, the 5 volts and the ground, to its respective pins. Here, put it right, the red color to the power. Now that's done connecting. Now we have to put the traffic light itself, the LEDs. So we go to the LED section, and here we go, it's the LED. And we're going to place it anywhere you want, but in this case I'll put it around here. So we can put any color, any number name you want. In this case, we're going to put the color to red because that's our first light. Second one, I'm going to put it around here. So this will be yellow. And the last LED is going to be green. So we put it as green. Now that we have the LEDs itself, we are going to put the resistors. So we click the resistors and we can rotate using R to make sure that we are able to connect the power to the LEDs anode. So we're going to put one over here. So you can use the default resistance. And another one so that the anode will be connected to the resistor. And then the third one. We rotate using R again. There it is. So now that all of it are connected, all the resistors are connected to anode, now we need to connect the Arduino to the LED itself. So first of all, we are going to use the yellow wire again, so it'll be easier to see. In this case, I'm going to use D2. Place it over here, and connect it to this part. As you can see, we connected, and the power will be flowing through here to the anode, and then traffic light will be light up. And then after that, the cathode will be represented by black wire and will be connected to the ground. Fix it a bit. There you go. See here, the cathode is directly to the Arduino in the ground pin. The same goes for the rest, so you can choose any pin. In this case, I'm just going to make it much more clearer. So this is 3. Go here, connect it to the resistor, and 4, go through here, connect it to the third LED, which is red. Now that we have all the way connected, we're going to use the ground again. So the cathode over here. Same goes with this one. And this. So this is the first traffic light, and we're going to do the same thing for the second one. So for the second one, going to put in the second area over here so that it will not disturb the first traffic light. You can put it also outside of the breadboard if you want, but in this case I'm going to put it in the breadboard so that it will seem more understandable. So I'll put it, the first light over here is red, and the second one over here, which is yellow, and the third one over here, which is green. Same thing, we're going to put our resistors as well. So use R to rotate, place it here, then it goes to this, and this one as well. So all the resistors are connected to the anode. Now we're going to use yellow wire and choose the pins, in this case D5, to connect to this wire over here, terminal 2. Might be a bit harder to see, so I'll use, in this case, blue. So now you can see it's connected to terminal 1 and anode for the green light. The next one, we'll use D6, this over here, resistor, and it's connected as well. And D7, the final pin over here, and to this one. That we're going to connect all the cathodes to the ground again. So zoom out a bit. So this one, since there is a bit lack of space, just going to go one whole round so that it will connect to the ground. Same goes for this one. Connect to the ground as well. There we go. And this one as well. Go. And everything is connected. Set to go. Except we're going to move on to the next section, which is the coding. So now we're going to move on to the next section, which is the coding section. Obviously, we want to make sure that this traffic light works as intended, so we need to actually do the coding. So when we go to this button here, which is code, you can see, in my case, it's empty. But if you have something over here, you can, for example, let's say we have this button or this slot over here. Let's say there is something here, we want to delete them. So you can delete them either by placing in this trash can symbol over here, or right click and delete block. So we want to make it empty initially, And then after that, we go to the control and choose this forever block and place it over here. So what this forever does, it will repeat the same instructions within its block. So within over here, whatever instruction is within there, until or forever, unless the Arduino is obviously deactivated, then it will not carry on that instruction anymore. So after that, we are going to first create our variables. This first one is distance underscore sensor 1. You can name it whatever you want as long as you understand it. So what does this distance sensor 1 do is that it stores the value of the distance measured by the distance sensor. For example, there's an object over here and it's 20 centimeter. Then it will store it into the code, into the variable itself. So go back to the code, create the second variable, which is distance sensor 2 for the second traffic light. Now that both of them are created, you can now first set the distance sensor 1. Click this set distance sensor 1 in the same variable area. 2, go to input, read ultrasonic sensor on trigger pin. So basically what it does, it reads the value that is recorded by the distance sensor. So place it over next to the 2. Now from this we can see that, let me zoom out a bit, you can see that it will read ultrasonic distance sensor pin. So what pin it does, that we can see from this is, assuming this is the first distance sensor, you can see the yellow wiring is going down here to this pin number D8. So now that we know that this is connected to the ultrasonic distance sensor 1 is connected to D8, go back to our code and put it here. So what it does is it sends the value to the pin 8. So we cannot do any pins as you want. We have to make sure that the pin is connected as is. So that's why we do that. And we go do the same thing, same as trigger. And then in unit centimeter, or if you are in other countries, you can use inches. Then for the second one, we are going to do the same thing for the distance sensor 2. So set distance sensor, change this, make sure to change this to distance sensor 2 to read ultrasonic in input. Ultrasonic distance sensor on trigger. As you can see here, this is D9. You can see this is the second distance sensor. It's connected to the pin D9. So we change this to 9. Same as trigger in unit centimeter. Now that it's connected, we are now going to, this is optional instruction if you want to print to serial method, serial monitor, which is this one over here. Basically it will, in this case we're going to put distance sensor 1. So basically it will print the values that is recorded inside this serial monitor. For example, there's 20. Let's say it's recorded in inside the variable is 20, so you put 20 over here. This is just to make sure that it's working as intended, and it will be easier to actually see how the whole traffic light actually works. But if you do not want to add this, it's alright. With new line, meaning it will go to the next row, and we are going to do the same thing for the second distance sensor. Print the serial method in the output. Distance sensor 2. After this, we are going to, as you know, traffic lights, the first light, both lights must be on simultaneously, but with different lights on. Or for example, there will be 3 red lights and then 1 will be green light, and then there will be, for example, 2 red lights, 1 be yellow, and then the other is also red. So we must make sure that both of them are on simultaneously. In this case, we are going to make this first traffic light in the FGHIJ row here to output high for the green light. The LED 4, name 4, green light. And the second traffic light to be red. So that's our initial state for the traffic light. So to do that, we go to the output, as we are here already, and click this set pin 0 to high. So as usual, just like the previous part, to read the ultrasonic distance sensor pin, we also see the pin that we want the traffic light to on. So in this case, this green light. As you can see, this is the anode. It will go through here to the resistor, to this yellow wiring, to pin number 2. So because it's pin number 2, we're going to set pin number 2 to high. So this means that high means that it will give out the power to the LED pin number 2. So basically LED will light up over here. And the same thing, since we want it to be red light over here for the second traffic light, go through the anode, see terminal 1, see terminal 2 of the resistor, and we see this blue wiring for the second traffic light goes to D7. So now that we know it's D7, so we click the set pin, drag it below set pin 2, and set pin number 7, as you can see here, to high. So now that we have both of the pins set to high, now we are going to add a weight. So what does this weight do? So basically, as you know, traffic light won't just immediately change red, green, red, green, yellow as it wants to. So we want to make sure that it has a pause so that the cars can go for a moment and stop for a moment. In this case, we add this weight block over here. Oh, not over here, but at the bottom. So let me get it out. Here, it's a bit troublesome to get it out, but you can get it out by making sure that the bottom part is taken out, whichever you want. Place it here and wait for how many seconds that you want. In this case, I want 3 seconds. So initially, it will show this green light and red light, and it will show that for about 3 seconds. And after that, we're going to run our instruction. So depends on what you want. You want to also make sure that the distance sensor records everything again, but in this case, I will immediately go to the next instruction. So I'll put if else. So what does if else do? If, let's say, the conditions is met, then it would do this instruction in this empty block over here. If it's not, then it will do the second instruction over here. So as you can see, there's a hexagon block. We go to math, and we see there is this 1 less than 1. Grab this and place it in the if block here. So what does this do? It compares two values, whether it's greater than or equal to, between one another. So in this case, we're going to compare the first distance sensor value so that it will execute that certain value or not, certain instruction. In this case, we're going to place this whatever distance you want, remember 200. So what does this do is, for example, if let's say distance sensor value is 300 centimeters, it is 300 centimeters is greater than 200, so it will perform the else statement over here. But if let's say the distance sensor is 50 centimeters, then it's less than 200, so it will perform this first statement over here. So what does this do is actually detect if there is a car within 200 centimeters, then it will do this certain instruction. So what I'm going to do is, in this case, we're going to add a wait over here for 3 seconds. So what does this actually mean is that it extends the instruction for the green light to activate for additional 3 seconds. But for the else statement, we're not going to do that. Basically, it will immediately go to the next instruction. So for after we put wait 3 seconds, after green light, the next logical thing that the traffic light will do is going to be outputting the yellow light. So obviously, we're going to go to the output again. As you can see here, we're going to look at the yellow LED in the first traffic light. Go to the anode. You see terminal 1, terminal 2. You follow this wiring. You hover over it. You can see where it goes to pin number 3. So we're going to take note of that yellow light is pin number 3. And then, before we do that, however, we're going to make sure that this green light is off. So, we're going to set pin over here. And we know that the green light is pin number 2. and set it to low. After we do that, we're going to set pin number 3, which is our yellow light, to high. Now that it's all high and low, that means that it will turn into basically the yellow light itself. After that, we're going to wait 3 seconds because obviously we want to make sure that it won't immediately go to the next instruction after going to yellow light. So you can, as usual, you can choose whatever seconds you want. In this case, I'll put 3 seconds again. And then for the else statement, which is what happens when the car is over 300 centimeters, then it will not perform, it will be the same thing except we do not have this wait 3 seconds in the initial part. So we're going to do the same thing, set pin to low, and then set pin 3 to high. So after we've done that, we're going, after yellow light, obviously it's going to be red light for the first traffic light. And if the first traffic light is red light, the second traffic light will do the green light. So in this case, we're going to set pin. Oh, before that, before I forget, or we forget, the yellow light must have wait 3 seconds so that it will delay the yellow, it will display the yellow light for additional 3 seconds. So after that, we set pin for the red light of the first traffic light. We go through the terminal 1, terminal 2 of the resistor, and we go hover over the wiring of yellow, which indicates the first traffic light. Go through here, and we can see that it goes to the pin number D4. Now that we see that it's D4, go back to our code itself, zoom in so that we can see a bit clearer. We're going to set pin number 4 to high. And then before that, however, we have to put the yellow light, which is over here, which we know is pin number 3, to low. The same thing as what we did for the green light and yellow light. However, this time we have an additional step, which is for the traffic light number 2, which, as you know, the red traffic light, which as you can see, we go to anode, terminal 1 is at pin number 7. So we want to make sure that the LED for red traffic light to be low or high, low or off. So we put pin number 7, scroll down, and to make it low. So now the red traffic light will be low, and of course, when the first traffic light is red, second traffic light will be green. So we set pin, and we try to go to anode again, see the blue wiring, and we can see it's D5. So set D5 to high. So now that D5 is high, we can go through. Of course we're going to wait 3 seconds because we do not want to make sure. We want to make sure that the green light for the second traffic light will stay for at least 3 seconds, or any value you want. We're going to put 3 seconds. And then we're going to do the same thing as what we did previously for the first traffic light. We're going to put if not if then, if else, not if done, and then put a mask. Grab this the compare block into here. This time, instead of distance sensor 1, we're going to put distance sensor number 2. So when we go here, you can see that it's less than something, and the same thing, we're going to do the same thing as the first distance sensor. We're going to put it 200 centimeters, so we'll detect whether the car is within 200 centimeters or not. In this case, we're going to put it lesser than equal to. Same thing for this one actually, we're going to put it lesser than equal to. Depends on how you want to see your value. And then we're going to go to the output. After you wait 3 seconds, if it's true, let's say if distance sensor 2 is actually less than 200 centimeters, then we're going to go to control and delay an additional 3 seconds for the green traffic light, or for traffic light 2. So we go to 3, type in 3 here, And the same thing as the previous traffic light. After the traffic light number 2 is green, it will go to yellow, and for this case, this one was the traffic light 1 will remain the same as red. So we go to output. We're going to set pin. We're going to set this green light to low because we want to make sure that's off. Set to low. Set pin number 2. That's the yellow traffic light to high. So as you remember, this is D5 for the green light and D6 for the yellow light. Go here, D5 to low. See here, this is over it, and then you can see D6. Scroll down, see D6 to high. So after that, same thing as previously, we wait 3 seconds for the yellow light so that it won't immediately go to red light. Go here, yeah, 3 seconds. And the same thing for else, except without the additional delay for the green light. So we go to output, set pin number 5 to high, to low, not high. And set pin number 6 to high. And then wait for 3 seconds for the yellow light. So after this, now that we have done the second if else statement, we are now going to make sure that this yellow light, the traffic light number 2, will go to red light. Meanwhile, this light over here will go to green light. So we can put that. Actually, it doesn't really matter if you want to do this, but in this case, I want to do it so that it will be understandable for you. I'm going to set pin. The reason why I say this doesn't really matter because the first statement, as you can see here, at the end of the statement, it will loop back to the initial statement, which as you can see is set pin 2 to high, set pin 7 to high. So it will set pin green light to high, red light to high. But if you want to make sure that it works or something, you can add this as well. It doesn't really matter. It doesn't affect your circuit that much. So you can set pin 2 to high. But before that though, we have to set pin, the yellow light over here, to low. So in this case, it's going to be set pin 6 to low. The yellow light for traffic light 2, make sure to remember that. And then, now we can do the set pin 6. And set pin 2 to high. And set pin number 7 to high. So basically, both of this are going to be, high. And if you notice, previously, when we execute this instruction over here, set pin 5, which is, no, not set pin 5, the set pin 4, which is over here, which is our red light over here. As you know, we are going to set this to green. So we have to actually put this red light, the set pin number 4 over here, to low, so that it won't have 2 lights on simultaneously at the same time. So we're going to add another instruction over here. Going to set pin number 4, which is our red light for our traffic light 1, to low. And that's all. You have done your circuit, and now we can test it out in our code when we start the simulation. So now that we finished the coding part, we're now going to simulate it to test whether it is actually working as intended. So we go to the code and open up the serial monitor. You can just click over here and you open up the serial monitor so that we can see whether the distance is correct as it's input by the distance sensor. So for the first distance sensor, when we start the simulation, as you can see, the first distance sensor is set to 270.2 centimeters, means that there's an object detected around that area. And for the second distance sensor, we can see that the object is within 87.6 centimeters. So meaning the traffic light 2 will detect there's an object, there's a car within its distance sensor radius. And for the first traffic light, there is no car within its traffic light distance sensor radius. So we first stop the simulation. We're going to restart the whole thing again. We're going to clear this. And now that we know what the distance sensor actually detects, we're going to start the simulation. So in speculation from the code, the green light will be, for the traffic light 1, will last for just only for 3 seconds, while the green light for traffic light 2 will last additional 3 seconds, as you know from the if-else statement over here, because there's an object or a car detected within the traffic light. So when we start in simulation, you see green light for around 3 seconds. You can see it goes to yellow light for around 3 seconds, and goes to red light. And this one will be green light. It will last for 6 seconds, as you can see. So at 12, it goes to yellow, and at 15, it will go to red. And it will repeat itself unless we change the distance sensor object detection. So that is all for me. I hope you have a great time and are able to actually do this traffic light together with me, and it works as what it's supposed to be. So that's all for me. Thank you.